Let's take a look at this React take-home assignment. Looking for feedback, why was I rejected? I'm a junior developer with just a little over 1 year of experience, and I've been trying to look for a new job. In brief, I received a take-home assignment that entails the following. Build a full-stack chat application. The React Native application comprises of 3 screens. We have the authentication screen, the all chats screen, and the one-on-one chat screen. Use WebSockets to manage real-time communication between users, integrate it with a database, and implement efficient data rendering. Now, when they say efficient data rendering, I suppose 1, use something like pagination or, well, infinite scrolling, and 2, a virtualized list. Because if a chat has over 10,000 messages, you're obviously not going to render all of them at once. What you're going to do is only render those that the user can see. And as they scroll up, you remove those from being rendered and render the new ones in the viewport. Anyway, despite lacking experience with React Native, I've worked with React. So I asked them if it's not a problem, and they assured me that it's acceptable as React Native is essentially the same. I tackled the take home, investing approximately 8 hours. I'm not well versed in React Native's best practices, so I just used the React navigation library, although I did encounter the Expo file-based router, but I still went over and used this library for simplicity, especially since I do not have experience with React Native. Sure, there are a few considerations to note, such as the handling of authentication. I implemented a basic bare-bones session auth and WebSocket management. For example, directing messages to connected users rather than broadcasting them to all of the users. But keep in mind, this is a take-home, and absolute production readiness is neither expected nor recommended. And this is true. Sometimes it's best to go above and beyond with these take-home assignments, but in the end, no one is expecting a production-ready application. And if they do, run away. I tried using Native Wind. Tailwind is just great for prototyping, pushing out styles fast, but I noticed it doesn't work well with aligning content for some reason. Try to align the left-hand side of the chat with the notifications, and for some reason it just didn't work with Native Wind. And once I copied those exact styles, but with the CSS in JS, it worked just fine. Sure, there's a clash between sometimes using the native styling, other times using Native Wind, but again, it's a take-home and it's unfeasible for it to be perfect. To be honest, this was a little bit of an extensive one, so I didn't want to devote days on end. Here's the repository. I set up a basic monorepo with an X, defined the API with TRPC, connected it to the Express server, and the React Native application just consumes these API contracts. In short, you can create a new chat, send messages, infinite scrolling, and messages are marked as read. Here's the WebSocket logic, and one thing that could be improved right off the bat is the logic for marking messages as read. And okay, well, they seem to be suggesting something, so let's skip this for now. Anyway, I would appreciate your feedback. So let's check the comments. Let's see what people think about this take-home assignment. First comment, that's a lot of work for a take-home, I would say. Implementing a full live chat application with sockets and database integration as a junior React developer take-home assignment. Someone in management has been smoking a lot of pot. The company thanks you for their new product launch. That's a good one. That's multiple days of work. If this is a junior level interview assignment, I am effed. And then some feedback here. Another one, I've got a little over 10 years of experience and my head is spinning reading these requirements. No way I would do this. As we can see, the general consensus is this is too much for a take-home assignment, and I agree here. So I was contending whether to run this project locally, and I decided to do so. So I just followed the instructions in the README, and I was able to, well, run this with my Android emulator. So we have the emails. So for that, if you run the db seed, you should get some users created for you. So we have John at example.com. As we can see, we have some form validation here. And then when we click login, we get taken to this chat screen. And then we have Melissa at example.com. So again, with the database seed, we get all of these conversations added, and this is well to populate the database. So now we have John on the left-hand side, and we have Melissa here. So now if I open the conversation with Melissa, as we can see, we get all of the messages loaded. And if I come here over to the conversation with John, as we can see, everything is loaded just fine. And we have these red messages. As we can see, this message has not been read. But if I scroll up, the message is red. And since this is using WebSockets, then the message right here is now marked as blue. So if I keep scrolling up, we get the messages marked as blue and so on and so forth. And we also have infinite scrolling, so we can keep scrolling up until we get the end of the messages. So we get this nice little spinner, and it is going to fetch the messages for us. As we can see, we get the last messages. Now this is running slow for me because I have two emulators running, and I have my database client, I have Docker running, and I am also recording on top of all of that. So obviously the performance will not be the best here, but you get the gist of it. Now what about sending messages though? Well, if I come here, I'm here at having a conversation with John and here with Melissa. So I can say, hey John, send the message. And as we can see, via the power of the WebSockets, we get the message instantly. And it is marked as read, well, because this person is viewing the message, obviously. Now let's test it out. If I scroll up and then say, hey John again, we get hey John again, but it is not read. Now if I scroll down, and this will now be marked as read, and then I can say, hey Melissa, or maybe I'm getting this wrong. I believe this is a conversation with John and this is Melissa, although I'm not entirely sure. If I come back here, yeah, this is John. So I messed up the different clients. So in this case, the left-hand side is John and not Melissa. So this should say, hey John. Anyway, this is how the application works basically. And then you can come here and start a new chat. So let me check the users populated here. So we have Robert. So we can say Robert at example.com, start chat. And as we can see, we now get the chat screen, but with Robert. So now let's check the code. Okay, so I opened it up with github.dev, which is the web version for Visual Studio Code. So at a glance, we can see, well, this is an NX project. So we have tools, we have Prisma, well, for the database, we have the libraries and the applications. So the server, I suppose this is the Express server they were talking about, and the mobile application with React Native. Now, if we head over to the README, as we can see the installation, so we're using Yarn. We can initialize the database for development with a Docker. So they provided a Docker Compose and the .env, and they also have seeding for the database. So I guess under Prisma, then seed. Okay, so some conversations, and then they have for running the server and the mobile application. And then a structure. The Express server is located in apps/server. The React Native client is in mobile. And the API logic with TRPC is in libs. So this one. And the API contracts are located in API contracts. Okay, so we have the database. I suppose this is for the Prisma client. So if I come here to lib, then db, yes, we can see this is like the singleton pattern, but well, for an instantiated class. So we have this module, and it is going to check if it already exists. If it does, then just use the already instantiated one. So again, this is a singleton. So this is to avoid having a lot of connections to the database. Okay, so next we have the source/lib and then the API. So here they define the context for TRPC, then they create this T utility. So as you can see in T3 stack, they do the same. So you can say T dot procedure and so on and so forth. So this is just to leverage, well, the context type. So everything is correctly inferred. Then they have the error formatter, and then they have the logging middleware. So they simply log how long the request took. So request timings, as we can see here. Then we have the TRPC procedures. So we have public, just use the logging middleware. And they also have the protected. So this is the minimal bare bones session authentication they were talking about. So without a middleware, they get the request, then they extract the cookies. So if the cookies exist in request, then the request is of type TRPC express, create express context options, and then they assign the cookies to these cookies. Otherwise, it is going to be in headers. Okay, so this is a common workaround you have to do when dealing with requests that may come from different sources. So for example, if you just have an Express endpoint, well, the type will be this one. But if you have a WebSocket server, WebSockets don't have the same structure and type definition as Express does. They may have different ones. In this case, the cookies that come from the WebSocket server, in fact, does not have this .cookies property. So in this case, what you would need to do is get the headers, and then you'd have to split the cookies from the headers. So for this, they just use parse cookie, which is going to abstract the vast majority of the logic here. And then they throw an error if there are no cookies, and then they debug this error, and then they have the session cookie, so casted as unknown, and then they use sod to make sure that the session is of type email. So well, they did say this was minimal. They're not using JWTs or something of the like. So they are just using sessions as emails, which can simplify the logic a lot. So if it's not success, they just throw a forbidden, which is great. Then they find the user where the email is this one, and then they are pretty much authenticated. Now, obviously, if this were to be a production application, you would never do this because anyone can spoof the session. They can just send in the session cookie to be another person's email. And now they have access to everything pertaining to this user. But for the simplicity of a take-home assignment, this is completely fine. And then they call next, and they pass in the context with all of the user information. And then they use unstable pipe to chain another middleware, which is going to be the logging middleware. So now let's move on to the app router. So they have two routers. They have the auth router and the conversation router. So if we come here over to routers, let's take a peek at the auth router. So they have user select, ID and email. Then they declare the auth router, and then they have the login. So they set the cookie, if they can, obviously. Now this could be improved a little bit, and that is separating what comes from the WebSocket and what comes from Express itself. Because every time you're going to access the response or the request, you'd have to do this check every single time. So for that, I would create another one, so like WebSocket procedures or something of the like, so that we get that clear separation of when we can access something and when we can't. In the case of the WebSocket server, you would never, well, make a request where you would access the response to set the cookie to the session, since this would be handled by Express. So that's one improvement I would make for sure. Then we have the me endpoint, so they get the data of that particular user, and then the sign out. So as you can see what I was saying, if we separate these so that we can access Express procedures, we wouldn't need to do all of these checks over and over again. Okay, now let's move on to conversations. So we have the message select, they have ID, content, well, all of this information, and then satisfies prisma.message select. So this is actually something that is very useful in Prisma, and that is, do you need to reuse selects? So you have a lot of queries that use the same select. For that, you should be using satisfies because you're not overriding the original type. So you're not getting rid of the fact that this object contains ID, content created at, all of these as true, but you still enforce the type. Now, what I mean by this, if you were to set prisma.messageSelect to the type and not satisfies, now if you were to access ID, I believe it would be a partial boolean, and then partial boolean, and then when you pass it over to Prisma, you get an unexpected outcome. And that is, well, Prisma bases the results of a query based on the select. So if you pass in this one, which is booleanify, like a partial booleanify of all of the properties available in a message. So then the resulting query, so the data that you get from the database, is now inferred as everything being optional. So this is very important when working with Prisma, and then they have the type for the message, and they get the payload. So yeah, this is a utility, so Prisma can get the resulting type of a select. So that's why they pass in select is the type of message select. Then the add response, my events, and event emitter. Okay, so this has the logic for the WebSockets. So this is just a simple pub sub mechanism. So they have the event, so we can add something, and that's something, I believe it's a message. So we can send messages back and forth and then mark as read. So message ID and read add. Okay, so this is for marking the messages as read. So those checks that appear in, say, WhatsApp when a user reads another person's message, and then they declare the event emitter and they create the class, and then they instantiate this class, and now they have this event emitter that uses my events type. So this is great in terms of TypeScript support. You get full type safety here. Then they export the conversations router, they create the router get all, and they have this raw query in SQL. Could have been a limit on Prisma send, who knows? And then they return the conversations. Then they have the infinite query. So they take in a cursor and then take how many messages the client needs to take, and then the person they were having a conversation with. So this is great. They're using cursor-based queries instead of actual pagination with the offset, which is way more performant. So they get the take, the cursor, otherwise null if there's no cursor. So I suppose if this is the very first query, the cursor will be null because the client doesn't have that one to pass in. Then the other user, they check if the other user exists, and then they retrieve all of the messages where the user is either the sender or the recipient. So let's actually check the schema. So this should be a schema.prisma. So they have a model user, send messages and receive the messages. They set up two indexes for the email and phone, and they have the message. Okay, so this makes sense. Although I'm not sure if this would be the best database design, but again, this is a take-home assignment. No need to be pedantic about this type of stuff. And then they retrieve the previous cursor if one exists. So they get the last date stamp, which is going to be the previous cursor. Okay, so as we can see, this logic is pretty rudimentary. This is what you would do if you were to use cursors. And then the send message, they have a mutation for that. They add a message, so new message, and then they use the event emitter to emit the add. So now we have a side effect here, which should be handled here, as we can see on. So like an event listener, it is going to listen for this emitted message. So whenever a mutation occurs, so when a person sends a message, what it is going to do is emit an add message. It is going to pass in the new message and then the destinataries. So the people where this message is destined to arrive. And then the subscription will simply emit to each client the data. And same for mark as read. So you pass in the message ID and then you update the message. So it is read out when the server processes the message, and then they emit the message again saying, hey, this user just read your message. So the client knows what message to mark as blue, like in WhatsApp. So yeah, this is pretty much a clone, a minimal clone of WhatsApp or Messenger. So this looks good to me. Now, obviously, all of this is crammed up into a single file. You would separate these. I would have like a class for the WebSockets. So you can pass in, say, a generic with the events right here, and then you can abstract all of these. But I get it, this is a take-home assignment. Okay, so now let's move to the front end. So the React Native application, we have the mobile. Under source, we have components, then library, we have hooks, stores, types, and utils. And we have some layouts here, and then UI. This is pretty similar to ShadCN's structure. And then they have the app directory, and then they have the index. So, okay, this index is just a root with the TRPC provider, and then the layout, which is this one here. So they create this stack for the navigation, they declare this layout, then they use this session. If the session.status is equal to loading, they return the loader. So let's check this use session hook. So this is defined in libhooks use session. So libhooks use session, they have the type, so user status, refresh, and sign out mutation. So use session, then they have the auth store from stores. So this one right here. So they have the me output, the store API, and they are using Sustant for this. And they initialize it with null, then loading, and then they provide these two methods. So if we come back here, they have the me query, the sign out mutation, and then they return all of the data. So this looks good. Then they return and they have the different screens. So if the user is unauthenticated, they return this login screen. Otherwise, they return all of these screens. So the home screen and then the chat screen, and they pass in the route and route params for the props. So let's go one by one. Let's come here over to the home screen. So home.screen. And as we can see, they have a little bit of logic here. Open new chat modal. They have is focused, conversations query. So they get all of the conversations the user has. And then they have an effect where they subscribe to the focus event, and then they refetch every time the user focuses on the screen. So I suppose this is a way to have that refetch on Windows Focus, but well, in React Native. And then they get the conversations and they just render a flat list with the conversations. And for each one, they render a pressable, which is basically a button, and they navigate over to the chat screen and they pass in the email to be the partner email, and then the chat row, and then the key structure. And then they have the pressable, so this is a button that opens the chat modal, and they render the chat modal. So let's come here to new chat modal. And as we can see, they're using a React hook form with the form schema. So this is pretty basic. This is something you would see in ShadCN as well. And then they get the session. They have some rendering logic here, pan responder, etc. And then they render the actual modal. And they render this controller with the text input, enter recipient's email, and then they simply return back an error if, well, the form schema validation failed, which is this one. So for example, you cannot start a chat with yourself, so they are making sure that the user cannot type the session's email, because you shouldn't be able to chat with yourself Although you could, in WhatsApp, I believe you can chat with yourself, but I guess this is just some simple limitation and the showcases use of validating the form data. So they simply render these controllers so a controlled input, and then whenever the value changes, they update the data, and then they have the button for starting a chat. So they invoke the handle submit, they get the valid values, they reset the form, so they reset this text input data, and they invoke this unsubmit, which comes as a property, okay? So when the data is submitted, they log the data and then they navigate over to the chat and they pass in the email. So this looks good to me. Maybe fix this up. Seems quite odd to have like this unsubmit when you should provide like a better separation of concerns. You should have the unsubmit within the chat modal and instead just pass in this navigation property. But I guess it makes sense if you do not want to nest the navigation property. Although I'm not very familiar with this library, maybe they have a hook like use navigation similar to React Router, but either way, this is fine. Okay, so now the chat row, let's see what this entails. So they have has unread messages if the message.unread count is greater than 0, and they render the partner email, the content, and then the status container, which contains the created ad and the unread count. Okay, so this is the view where you can scroll over all of your chats, like in WhatsApp, where you can click on a chat and it is going to send you over to the chat screen with that person. But as we can see, they also declare this avatar component within this component. Now, this is fine on the off chance that you really need to do this, and there's really no other place to define it if it's specific to this component, but generally speaking, even then, you should extract these components over to their files. And furthermore, this avatar container looks like it should or could be used in a lot of places. So for that, what I would do is create this component at like the root level of all components. So any component can import this avatar and use it however they want. But other than that, this looks fine. Okay, so now let's come here over to the chat and let's come here to the chat screen. Let's see what this screen is about. So they have const other user email, so route.params.email. So this is the prop that is sent with the pressable link. So if we come over back to home, then home.screen, here they're sending over to chat this property right here. So they're sending the email of the recipient. In this case, we're accessing that recipient email, and then we get the session, and then they get the current user email. So at this point, we have two emails. The one of the other person this user is having the conversation with, and well, the email of the current session. Then they have the messages query, so infinite, use infinite query. So this is the one that uses the previous cursor. Okay, so this is nice because React Query abstracts a lot of this logic out of the box for you. As we can see, all you need to do is pass in this get next page param, and then you get the last page, which is like the last item, and then you access the previous cursor, and they pass in, well, the other user email. Then they declare the messages, so messages query data, then pages, and then flat map. Now I'm not sure what this initialization is doing, because in the first render this will be null, so this will not be set. And if it re-renders, so when this hook returns the updated data, so once it has finished loading the query or fetching the data, the use state will not be re-initialized. In fact, if it's initialized once, no matter what changes, it is going to keep that initialized data. Although now that I think about it, I believe this is used for the cache that comes with the use infinite query, because in React Query, when you perform a request, it is going to cache that data. And I believe it's for like 5 minutes. So if the 5 minutes pass, then the cached data will be considered stale. Hence, it will perform the same query again. So if that's the case, then this makes sense. Because if you go back and forth between different messages, I believe it is going to rely on the cached data. But I'm not entirely sure if that's the case here. Then they have the add messages. They use a callback. They get the incoming messages. So I believe this is the new messages. And then they set the messages. They get the previous messages. And then they create a map, which has a string and then the message. So they store the ID in this map. So like map.set in this ID, and it is going to be this message for the current, so the previous messages and the incoming messages. So this is interesting because what this is doing is automatically deduping the messages. Deduping is removing duplicate data. Because if there's a new message coming in with the same ID as a previous message, what this is going to do is override the message that came from the previous messages. So again, this is a way to remove duplicates. And then they return the object.values and then they sort it by created at descending. So this looks fine, empty dependency array to avoid reinitializing this function every single time. And then they have this function mark message as read. They pass in an updated message ID. And what it is going to do is simply get the new message. Going to find this updated message and set the read at to be a new date. So this is doing it optimistically. It's not, I believe, waiting for a response, but rather it is setting it to read at to this date right away. Now, the reason I believe this is optimistically updating it is because there's no argument for passing in the read at date that would come from the server, which is actually the source of truth of when the message was read. Then they have mark as read mutation, so they initialize this mutation. They have the view config reference, so view average % threshold. And then they have unviewable items changed ref, and they stored a function. They get the viewable items, they get each message. So as we can see, an array of messages, and then it marks the messages as read if they are from the other user and not already read. So what this is going to do is simply filter out and find the messages that are not read, but are in the viewable viewport. And then for each one, they mutate. So they perform a request over to the server saying, hey, the client just read this message, so mark it as read. And then they optimistically, as I said, mark the message as read, instead of waiting for the result. And this makes sense because if you open up a chat with someone, you know that the instant you see the message, that's when you read the message. Like technically speaking, obviously we're not accounting for when the person actually reads the message in their head. In that case, it would seem odd to see like a 2-second delay potentially, or if the user has a slow connection, 5 seconds to see that the message has been read. That would be a terrible user experience. So in this case, it's great that we handled it optimistically. And then they have the use state. So every time the messages query data changes, then it is going to add the messages. So again, this is interesting because what this is going to do is deduplicate the messages. So as we can see, it is invoking this function right here. So it is going to get rid of all duplicated messages if there's any. And then once the component is unmounted, it is going to reset the messages to be an empty array. So as we can see, this is important because add messages is in a use callback. If you got rid of this use callback and just defined a function and then you used it here, it would cause an infinite re-render of this use effect. So an infinite loop, which would crash the application. And the reason is because, well, this is invoked, add messages is invoked, messages change, which are these ones from this state. This is going to cause a re-render, and with the re-render, the function will be recreated. So when it gets recreated, what is going to happen? Well, this dependency will now trigger the effect to run again. So you're getting an infinite loop of re-renders with this use effect. Anyway, let's move on. So now they have the subscription. So use subscription, no input, and then they have all of these callbacks. So whenever data arrives, so when a new message arrives from either themselves or the other person, it is going to check if the message is for this user. And if so, it is going to add the messages to the already cached messages. Now, this isn't ideal because this means that the data is being broadcasted to all WebSocket clients. So that means that someone who doesn't partake in this conversation will still receive this message. Now, this would be totally fine in a world where anyone just minded their own business, but we know that's not the case, and people will play around with the network tab and see how they can exploit the application. So in that case, well, everyone would be able to receive the messages that shouldn't be seen by them. So this is a privacy leak. So for this in your WebSocket server, you would have like a map with all of the connected clients, and then you would send or emit only those messages to the connected clients. So like a pool of connected clients. But well, this is a take-home assignment, and I wouldn't expect more than this. And in case there's an error, so when the subscription is not connected successfully, I suppose, or perhaps there's a network error, or who knows what else, then it is going to invalidate the messages. And the reason is we might have missed some messages, so we need to invalidate the query. So this is great. They also handle errors. And then the unmarked as read subscription, and then they just invoke the mark messages as read, which is this one. So set the messages and find the message we need to update, and that's it. And then we have this load more function, and it is going to check, is there a next page? So is there more data? If so, then fetch the next page. And that is, well, of course, if the query is not fetching the next page. That way we can avoid potentially hundreds of requests to the server. So in a way, this is debouncing the trigger for fetching a next page. And then they render the flat list. So the messages, they render a message bubble, they have the key extractor, then on end reached, so load more messages, then there's the threshold. Maybe this should be upped more than just 0.1 to like 0.3 or something like that. So it's a better user experience. So as you scroll up and you see the messages, it is going to automatically fetch the next page instead of you actually having to go over to the top, which I believe would be the case here. And then the list footer component, and they render this activity indicator, which I believe is the native component for that spinner you see, for the loading spinner, whenever there are more messages being fetched. So this is great. The user gets feedback on whether we're fetching a next page or if that's the end of the messages. And then the viewability config, and then whenever the viewable items change, we simply invoke the function, which is the current. So the current is the function that is stored in this ref. So again, the reason they use this ref is to avoid the function being recreated every single time. So optimization. And again, this could be changed to a use callback with an empty dependency array, whatever floats your boat. And then the send message form. So I guess this should only send the mutation, so send a message, and then this subscription right here will handle everything for you. So let's confirm this. If I come here over to components, send a message form, we have the send message mutation, use form with the SOD resolver, so the content minimum 1 character, and then they mutate async and they pass in the content. So in fact, it is doing what I thought it would do. And when the message is sent, the server receives the message, and then it is going to notify or emit this event to all of the connected clients. Now, this could also be improved. If you want, you can add this message optimistically. So instead of the user again sending a message and potentially waiting 3 seconds to see their own message sent, it could be added automatically. And if there's an error, you revert that optimistic update, which now that I think about, it's not being handled here on the mark message as read. So in fact, if this fails, all of these messages should be reverted back to the previous state. So I believe that's all. We have the login screen. Okay, so just a login form, and they simply set the session to be the data they get from the login mutation. So nothing fancy here. So I believe this is everything. So what can we take away from these? What can be improved here? Well, first of all, you could extract this into its own hook, like a use chat hook, and then you would say like const chat, use chat, or something like that, and then you can say chat.add, and then chat.mark messages as read, or you could have chat.load more. You could invoke this method, or you could get the messages. So messages, and you could render them. That way you can also decouple the logic from the component to its own hook. But that's completely optional, and in fact it depends vastly on how the project is structured. Is it worth it to extract that? Because in this case, while it's true we're rendering data here, this is not the main component of this component. This component is really just worried about the business logic, which is this one, sending the messages, or well, getting the messages, marking them as read and whatnot. And in fact, the rendering comes here in the message bubble, in this one. So session is current user, and as we can see, the logic for actually rendering each data component is abstracted into this message bubble component. So again, for me, this looks fine. And if this keeps growing and growing, you can perhaps just separate bits of this into their own utility files and import them. For example, for deduping the messages, you could extract these to, say, a function called dedupe messages. So you could say set messages, then dedupe messages, or something like that. And now it is clearer, but everything is still being handled within this component. So as we can see, this is a very hard take-home assignment, and this would take a lot of time. Even more if you're not familiar with something like WebSockets. If this is the first time you're doing WebSockets, this is obviously going to be harder. Now, would I personally assign someone this type of take-home assignment? Of course not. Not because of its difficulty, but because it's very extensive. It could take potentially days, and barely anyone has that much time to devote into a single take-home assignment when you could have interviews lined up for many companies. But anyway, I hope you learned a lot with this take-home assignment, and I would in fact, if you're interested of course, invite you to solve this challenge from scratch. Use your own technologies. If you want, use REST or GraphQL or whatever you want. Either way, this is a great learning experience. If you want to see more content like this, make sure to subscribe. I'll see you soon.